Hello students, in previous sections we have taken examples on complex number using operations on complex numbers. Today, firstly I will state some properties of modulus function and we will use that properties while solving the examples. Okay, so properties of modulus. So the definition, if z is equal to a plus ib belongs to C, not modulus, then its complex conjugate is z bar is equal to a minus ib. Okay. Properties. For z1, z2 belongs to z, z1, z2 belongs to C. If I have complex number like this, first z into z bar, a plus ib into a minus ib, a plus ib into a minus ib. If you simplify this is precisely a square minus I square b square, but I square is minus 1. So a square plus b square, since I square is minus 1. And therefore z bar is equal to a square plus b square. Okay, and it is precisely mod z square. So this is the important property, first important property. Second, I am not going to prove each and every property. z1 plus z2 bar, conjugate of addition of two complex numbers is same as addition of their complex conjugate. If you have to prove it, take z1 equal to a plus ib, z2 is equal to c plus id, then z1 plus z2 will become a plus c plus I times b plus d, and then its complex conjugate middle term will get minus sign, means a plus c minus b plus d I, which is precisely a minus ib plus c minus id. So on this line you can verify it. For minus, it is also same as this one. Third, z1 into z2 bar, conjugate of product of two complex numbers C is product of their complex conjugates. And fourth, z1 upon z2 bar, conjugate of quotient is equal to z1 bar upon z2 bar for z2 not equal to 0. So you can easily prove these properties and you can verify. 5. For complex number z plus z bar is equal to z equal to a plus ib, z bar is a minus ib. If I take addition, ib get cancelled, we will get 2a, and which is nothing but 2 times the real part of z. 6. If I take the difference, z minus z bar, then subtracting this from this, a get cancelled, ib minus minus plus ib, that is 2ib, 2bi, which is nothing but 2 times 2 times imaginary part of z I, 2 imaginary part of z I. B is imaginary part. B is imaginary part. So these properties are simple properties. These properties are simple properties. Then you can observe, if I take z into z bar is modulus of z square. Okay. 7. For complex number a plus ib, okay, for z equal to a plus ib, real part of z, a is equal to real part of z, this is less equal under root of a square plus b square, under root of a square plus b square, okay, which is nothing but modulus of z, modulus of z, and b is equal to imaginary part of z is also less equal under root of a square plus b square, which is nothing but mod z, which is nothing but mod z. Or real part of z square, real part of z square is less equal z into z bar. Okay, this is equivalent to say real part of z bracket square, which is a square, is less equal a square plus b square, which is nothing but z into z bar. And imaginary part of z, which is nothing but b square, is less equal again this, which is equal to z into z bar. So while solving examples, we require these properties of modulus function and complex conjugate functions. Complex conjugate functions. Yesterday I also explained powers of I. I raised to n for any n belongs to n. I raised to n. If I divide n by 4, it becomes 4q plus r, here 0 less equal r less than 4. Remainder, divide n by q. Applying division algorithm, if I divide any positive integer by other positive integer q, n equal to by 4, I will get some quotient, some remainder. Then you are writing dividend is equal to divisor into quotient plus remainder form. Just I am writing n equal to 4q plus r form. Then this is equal to I times 4q into I raised to r by law of indices. By law of indices. This is not 9, it is q, quotient. And which is nothing but I raised to 4 into to the power q, which is I raised into I raised to r. And then it is nothing but I raised to r. And then this I raised to r is precisely 1 if r is 0, it is again I. If r is equal to 1, I square is minus 1. If r is 2 and I cube is minus I. Okay, I am taking r equal to 3. This is very important while solving examples, and there will be lot of examples will be asked in competitive exam like JEE or CET exam. This powers of I raised to n plays very important role, and these formulas are very important while solving the examples. Now we will take examples from your exercises. So take the example, express say complex number 4 into I raised to 8 minus 3I raised to 9 plus 3 upon say 3 into I raised to 11, 3 into I raised to 11 minus 4I raised to 10, and we'll take some constant term say minus 2 in a plus ib form. Solution, a plus ib is equal to 4I raised to 8 minus 3 times I raised to 9 plus 3 upon 3I raised to 11 minus 4I raised to 10 minus 2. So firstly, if power of I is greater than 4, then divide that power by 4 first. So it is nothing but 4 times I raised to 4 into 2. This is 3 times I raised to 4 into 2 plus 1 plus 3 upon 3 into I raised to 4 into 2, 8 plus 3, that is the remainder. Okay, minus 4 into I raised to 4 into 2 plus 2 minus 2, and then I raised to 4 power, I raised to this power, that gives us 1. So this will become 4 minus 3i plus 3 upon 3 into I cube. This will become minus 4i square minus 2. Now we have to just substitute values of, since I raised to 4 is 1, implies this I raised to 4 cube is 1. Just I am using this one. So 4 plus 3 is 7 minus 3i upon I square is minus 1. So this will become minus 3i. This is become plus 4 minus 2, which is equal to 7 minus 3i upon 4 minus 2 is 2, 2 minus 3i. Then denominator never contain iota term. So we'll multiply its numerator denominator by complex conjugate of denominator. So this is 7 minus 3i upon 2 minus 3i into 2 plus 3i upon 2 plus 3i. Now z into z bar is a square plus b square. So we'll take the product of numerator, 7 into 4, that is 14, my plus 7 into 3, 21i minus 6i minus 3i plus 3i, that is minus 9i square. I square is minus 1, so we'll get plus 9, and here we'll get 2 square plus 3 square. Since a plus ib into a minus ib is equal to a square plus b square. Z into z bar is mod z square. So I am using that property here. Then 14 plus 9, that gives us 23, and 21 minus 6, 15. I upon 4 plus 9, 13. So this is 23 upon 13 plus 15 by 13i. This is your a plus ib form. This is your a plus ib form. While solving the example, it may happen there will be mistake in calculation. So if you observe there is some mistake in calculation, again check calculations, make the corrections and write the correct answer. Okay. We'll take now second example on this. Simplify. So if I take 1 plus I square plus I raised to 4 plus dot dot up to I raised to say 1000. If I take terms like this, then what will be the answer for this? What will be the answer for this? So this is equal to 1 plus I square plus I raised to 4 plus I raised to 5, I raised to 6, I raised to 7 plus I raised to 8 and plus dot dot etc. up to plus. This is my I raised to 1000, I raised to 999 plus I raised to 998 plus I raised to 997. So in this way I will correct the terms, because 1000 is multiple of 4. 1000 is multiple of 4. So this will become 1 plus I square is minus 1 and I raised to 4 is again which terms I cube remains here. So this is just up to I cube. Okay. Then I raised to 4, I raised to 4 plus, or we'll make adjustment in other way, 1 plus I square plus I cube plus I raised to 4. We'll take adjustment like this, plus I raised to 5 plus I raised to 6 plus I raised to 7 plus I raised to 8 plus so on up to I raised to 1000 here, because 1000 is multiple of 4, I raised to 999 plus I raised to 998 plus I raised to 997. Now you can observe this is multiple of 4, so this is 1 plus I plus I square is minus 1, I cube is minus I raised to 4 is again 1. I raised to 5, if I divide 5 by 4, I will get remainder to be 1. For this it is again 2, remainder is 3, remainder is 4. So I am getting same bracket here. For this also, if I divide it by 4, I will get I raised to 0, this clear. And then for this I will get I raised to 1, I square, I cube, and I raised to 4 means I raised to 0. I raised to 0. So we will get 1 minus I plus 1 and so on. So this terms will get cancelled and answer is 1. Answer is 1. This is the use of previous discussion. Now simplify. Say I raised to 592 plus I raised to 591 plus I raised to 590 plus I raised to 589. Oh sorry, 592, 590, 588 even terms and 586. Then we'll take 5 raised to I raised to 584 is also there in example upon I raised to 82 plus I raised to 580 plus I raised to 578 I raised to 76 plus I raised to 578. So from this 74. From this we'll take the lowest power term from numerator and denominator outside, which is equal to I raised to 584 in bracket. If I by law of indices, this remains I raised to 8, right? This is your I raised to 6. This is your I raised to 4. This is your I raised to 2, and this is 1. Upon this is again from this we will take I raised to 572 outside. We will get again plus 8 gives us 582. So it is I raised to 8 plus I raised to 6 plus I raised to 4 plus I square plus 1. So I am not interested to put values of I raised to 8, I raised to 6 because this numerator this is 574. Okay. This get cancelled. And then we will get I raised to 10 by law of indices. I raised to 10, I can write it as I raised to 4 into 2 plus 2, which is equal to I raised to 4 its square into I square. But I raised to 4 to the power I raised to 4 is 1, so I square is minus 1. I square is minus 1. If I take one more example of this type, say find value of 1 plus I square plus I raised to 4, 1 plus I square plus I raised to 4 plus I raised to 6 plus dot dot up to say I raised to 98, I raised to 100. If I take in this way, I can write this as 1 plus I square plus I raised to 4 plus I raised to 6 plus I raised to 8 plus dot dot etc. up to I raised to 98 plus I raised to 100. If I write like this. So here you can observe I square is minus 1. I raised to 6 is I raised to 4 into I square. I raised to 4 into I square. This is, if I divide 98 by 4, what will be a remainder? So 4 twos are 8, remainder is 1, then 4 fours are 16. Okay, so 26, 24. 24 into 4, that is 96 plus 2, so it is I square. And I raised to that 24 must be 1. So this is just 1 plus I square is minus 1, I raised to 4 is 1, this is minus 1 plus 1 and so on, minus 1 plus 1. This bracket takes 0 value, so we'll get 1 value. We'll get 1 value. And that's why these examples are important. Powers of I plays very, very important role while solving the examples. And such type of examples are useful for competitive exam. Now, take next example. If x plus iy is equal to a plus ib cube, a plus ib bracket cube, then show that x upon a plus y upon b is equal to 4 into a square minus b square. Now, some students will solve this example by equality of complex number. Means what they will do, firstly here, they will take a plus ib bracket cube and they will compare that, they will get x, y, etc. Here also I am going to take cube of this one, but instead of computing x upon a plus y upon b. Okay, so we'll find x and y first. Okay, so solution, x plus iy is equal to what is given, a plus ib bracket cube. We know that a plus b bracket cube is a cube plus 3a square b plus 3ab square plus b cube. That formula studied. So by using that, this is nothing but a cube plus 3 times a square ib plus 3 into a ib square plus ib bracket cube. ib bracket cube. Expanding it. So we'll get a square a cube plus 3a square bi. I square is minus 1. So we'll get 3ab square. I square is minus 1. And I square into I cube is I square into I. So we'll get minus b cube I. Minus b cube I. So this is our real part. This is your imaginary part. So this is nothing but a cube in bracket a cube minus 3ab square plus 3a square b minus b cube I, which is same as by taking here a outside. A outside. What will get? A square minus 3b square plus I times, by taking b outside here, 3 b in bracket 3a square minus b square I. This is your x plus iy. Comparing real and imaginary part. So this implies x is equal to a into a square minus 3b square and y is equal to b into 3a square minus b square. Therefore, x by a upon y by b. If I divide this by a, I will get a square minus 3b square plus y by b, b get cancelled, 3a square minus b square. A square plus 3a square, that is 4a square minus 3b square minus b square, so 4 times a square minus b square. Thus the result is proved. Okay. We'll take one more example. If x plus iy is equal to, under root of a plus ib upon c plus id, then show that x square plus y square bracket square is equal to a square plus b square upon c square plus d square. Till I have not explained how to find the square roots of complex number. If I explain how to find square root of complex number, then writing a plus ib upon c plus id in complex number form and then finding square roots, you can verify this also, but for this example there is some other technique. We know that given number into its complex conjugate, x plus iy into x minus iy, x plus iy into x minus iy gives us x square plus y square term. We have to use this somewhere. So firstly, we'll take square on both sides. So x plus iy is equal to square root of a plus ib upon c plus id implies is x plus iy bracket square is equal to a plus ib upon c plus id, squaring on both sides. Squaring both sides, we get this. Okay. Therefore, its complex conjugate. Okay. X plus iy bracket square is complex conjugate is nothing but a plus ib upon c plus id complex conjugate. We know that conjugate of product of two numbers, z1 into z2 bar is equal to z1 bar into z2 bar. So we'll get this to be x minus iy square is equal to a minus ib upon c minus id, since z1 z2 bar is equal to z1 bar into z2 bar, z1 upon z2 bar is equal to z1 bar upon z2 bar. Okay, so this is your 1, this is 2. From 1 and 2 now, from 1 and 2, we get x plus iy its square into x minus iy its square is equal to a plus ib upon c plus id into a minus ib upon c minus id. Again, z into z bar. So this is nothing but x plus iy into x minus iy its square is equal to a plus ib into a minus ib upon c plus id into c minus id. This is nothing but x square plus y square its square is equal to a square plus b square upon c square plus d square. Since for z is equal to p plus iq, z bar is equal to p plus iq into p minus iq is nothing but e square plus q square. We are just using this result. So that's why properties of complex conjugates also plays very important role while solving the example. So